Okay, our circuit is basically a bunch of automatic and manual switches that control our motor, and the RS flip-flop holds and keeps our circuit on or off, and the transistor is which controls our relay. Here's our circuit schematic for our circuit, and you should always be familiar with your schematic so you understand what's going on in the circuit. And you should know what each subsystem does and what each component does. Okay, here's subsystem 1 with the trim pot, and here's the LDR, and here's the operational amplifier, and there's the LED and resistor that completes subsystem 1. Subsystem 2 is here, covering all this here. And here's the stop LED, it's red. Here's our normally open push button, and here a resistor, and here's our RS flip-flop, and here's our start button, and here's our green LED resistor, and here's another green LED, and this shows the Q0 output. And Q goes to subsystem 3, which is connected to a resistor with a transistor and connected to a relay.
For subsystem 1, it's controlled by this trim pot and this LDR photoresistor, and the photoresistor works as the less light that's over top of it, the more voltage it will put out, and this variable resistor, you can change the resistance it puts out, thus changing the voltage it will put out. And they're both plugged into this applicational amplifier, and this applicational amplifier will put forth whatever voltage is higher, and it will send it to the second subsystem. And if the variable resistor is higher, it will send it to this switch right here, which is the reset part of the second subsystem. And if the LDR is higher, it will send it to this switch, which is an automatic switch, and it's the set part of this. Now this goes to a RS flip-flop right here.
Subsystem 3 is controlled by subsystem 1 and subsystem 2's outputs. As the circuit is cut on, either manually or automatically, the transistor is saturated. It acts like a switch and allows current to flow through the relay, which allows the relay contacts to connect, allowing current to flow through the DC motor. The LED turns on as well because Q0 is grounded, allowing current to flow through the LED, cutting on the LED. If the reset button is pressed, the entire circuit cuts off.
When troubleshooting, you should always make a flow chart to help you know what subsystem is wrong or if the circuit's operating properly. So in a flow chart, you're going to divide into each one of the subsystems. For our circuit, we had 3 different subsystems, and then inside each subsystem, you're going to want to go at each individual part, and you're going to want to find if that part is wrong, and then you can find the solution there, and then see if the rest of the circuit's working. We've set up 3 different problems inside the circuit, and we'll show you how to troubleshoot each one of them, find them, and fix the problems. We noticed something's wrong in our first subsystem because this last LED isn't lighting up. So we need to check the subsystem and see what's wrong with everything. So first we have to plug in this to ground, and the first part of the flowchart subsystem tells us to check if the voltage out of the trim pot is working. So we plug into the base of the trim pot right here, and then our oscilloscope now shows that that voltage is 12, so that output is proper, and the trim pot is not the problem with the first subsystem.
So we know our trim pot is not the problem, so now we're going to check our LDR. So to do this, we connect our channel 2 to the output of the LDR by plugging in And now we test our LDR by covering it up and looking at our oscilloscope. And as we cover it up, we notice the voltage increases, which is correct, so we know the LDR isn't our problem. Now we're going to check the output of the operational amplifier by connecting channel 3, which is purple, to the output here and to the ground. And now we operate the circuit, see if we get the right response. And that shows that the output is getting 12 volts. So we know our operational amplifier is working correctly. Okay, now we know that all our components of the operational amplifier, the LDR, and the trim pot are working correctly through our oscilloscope readings. We look at our schematic and we can see if everything's plugged in correctly, and then we noticed that the LED is plugged in incorrectly. It's plugged into the power line and it should be plugged into ground. So by fixing it and plugging it into ground, this should fix our problem. And now subsystem 1 is correct.
Subsystem 2 has a mistake because this light, regardless of which switch is pressed, is staying on. So something's wrong with subsystem 2. So first we're going to check the manual switch. Plug it in there. And if you look at the screen, when the button's pushed, it activates. So there's no problem with the manual input. Now, for the automatic input, we have to do the same thing. And you can see on the screen, if you cover the LDR, too much is covering the LDR, cover the LDR or push the button and it'll work. So both of the inputs are working properly.
Alright, now we're going to plug our outputs to the oscilloscope. So for channel 3 is going to be our Q output. So to do that, we're going to connect it here to the ground. And channel 4 is going to be Q0. Now we want to operate the circuit and see how it responds. And we can notice that our Q is always at 12 volts, and that's not correct until we press the reset, but it's latching at 12. So now we know there's a problem with our Q, or subsystem 2. We can observe and look at our schematic and see if we have all of our circuits or all our wires plugged in correctly. And then if we have all this correct, then we know it's our RS flip-flop that's the problem. So we want to replace that and see if it works correctly.
Now that we've changed out the switch, we see that when we push the manual switch, the light will turn off. And on the oscilloscope, the Q output is still working. And then when we press the reset button, the Q0 output will work and the Q output will stop working. So everything in subsystem 2 is working properly, and we can move on to subsystem 3. Now we see that there's a problem with subsystem 3. So we have to go through, and we notice that it's not latching and the motor's not turning on. Now that we know there's a problem with subsystem 3, there's two different ways to check if the transistor works. The first is to find a multimeter like this and plug in the transistor. And if we get a reading, that means the transistor is working fine. So the problem is not with the transistor. Now for the second way to measure or see if the transistor is working properly, first we're going to plug in a oscilloscope to the input, and then we are going to plug an oscilloscope across the transistor. Now on the oscilloscope, it should change, channel 2 should change when these buttons are pushed, but they're not. But since the first way to show us already showed the transistor was working, it must mean that there's nothing, or there's nowhere for the current to go in subsystem 3. So something must be wrong with the relay.
Alright, now we're gonna measure the voltage across the relay. To do this, channel 3 is plugged in right here to the ground. And then we'll connect channel 4 to the DC motor. It's the output of the relay. We operate the circuit, see how it responds to our inputs, and we can visually see that the relay contacts aren't making contact, so we need to check our schematic and look and see if we have everything plugged in correctly. And then we notice that our relay is not getting it's not plugged in, the power is not plugged in correctly. So once we plug it in correctly and we operate the circuit, we can look at the oscilloscope reading and we can see the correct outputs. And then our circuit is complete and it's correct. When building a circuit, you're always going to encounter problems, so you should always build a flowchart, a troubleshooting flowchart, and then use your oscilloscope to test each component and fix the problem and complete the circuit.